Hello students, so in this video we will learn about some more important concepts of electronics, and first of all I regret that this lecture is delayed by some time because in the last week I could not prepare the lectures. So let us start with our discussion without wasting further any time. And in this lecture what we are going to learn is the very important and fundamental thing for transistor analysis as an amplifier. And this is the small signal analysis of a transistor. Small signal analysis is very important because in the practicals, in the experiments when you are doing, small signal analysis is used. This is the basis of the H parameters that I will discuss in the next lecture, most probably 1 or 2 lectures later. And this is the fundamental thing, this is the portion of amplifier circuits which you should understand to further have a clear concept of amplification process, different types of amplifiers and all the technical details. So whenever we are discussing, we are analyzing the transistors for amplification purpose, it is better to consider the essential features and neglect those features which are less important. Because there are many features during transistor analysis that come in front of you, but those features can be neglected for the time being. And you can conveniently do the calculations and the mathematical analysis using the essential features. Now the first thing that is required for small signal analysis is to understand the meaning of small signal. What is this small signal? Because during Viva voice and during examinations, during interviews, this is asked that you are discussing small signal analysis, What is this small signal? What is the magnitude of the small signal? Because small and big, they are all relative concepts. You cannot define something which is absolutely small or absolutely big. So this is the fundamental question that we should know, we should answer. The basic definition of small signal is that when the current and voltage values are such that they are up to 10% of the Q value I have told it is a particular value of current and voltage. When your current and voltage are 10% of the Q value, then the signals are called small signals. And small signal analysis is required for the analysis of transistor as an amplifier. This is the basic first definition that you should know, that what is small signal, because suppose you are doing the practical, you are doing the calculations and you don't know whether your signal is small or it is a large signal, your calculations will not be proper. So if you are getting the current and voltage values less than 10% or up to 10%, not less than, up to 10% of the Q value voltage and current, in that case, the signal is said to be small signal. And when we are talking about signal, we are specifically discussing the AC conditions because that has to be amplified. Now the relationship between the input and the output signal, it is very important when you are discussing the amplification, because I have told you many times that the definition of what is the definition of amplification? Amplification means the input value is amplified or it is enhanced at the output. And we have roughly seen how does a transistor acts as an amplifier. So this enhancement, this shows that there should be a particular relationship between the input and the output signal. Now what is the parameter to discuss the input and output signal relationship? This input, there is a particular relationship between the input and output signal, and it is expressed as the function of the frequency of the input signal, and it is called the transfer function. Transfer function is basically a mathematical concept. we are interested, the parameter that is of interest in case of study of amplifiers as transistor amplifiers is the gain. This gain is actually defined as the magnitude of the transfer function. So, when we are designing a circuit for amplification using a transistor, it may be NPN transistor or PNP transistor, what are the basic steps that we should follow? The first step that we should follow in the designing of an amplifier is the most important thing, which is the Q point value. Q point means quiescent point. I have told you, you can see the previous lectures. Quiescent point value. Quiescent point means at this coordinates VCE and IC, collector current and collector emitter voltage, this should remain static and it should lie at the midpoint of the DC load line. We will discuss the AC load line shortly. First you have to understand these basic concepts. Now how can you fix the DC bias or the Q point? What you do, we have discussed in the previous lectures that this can be done by applying a DC bias circuit that fixes the Q point, and we have seen the bias circuits, bias stabilization, fixed bias, self bias, base bias, collector bias, feedback bias, all these things we have seen. Sorry. Now the requirement for amplification is that an external signal, when it is applied to the input side of the transistor, it should appear at the output end in enhanced form, in amplified form. But this Q point should remain unchanged. This Q point should not change. And this is the definition of faithful amplification we have studied in the previous lecture. This Q point should remain unchanged. It should not change. Then only it is a faithful amplification. Faithful amplification means the shape of the output signal is same as the input signal. And the output signal should be same or in proportion to the input signal, which is the meaning of faithful amplification. Now let us see this circuit. You can find this circuit in the book by Millman and Helkias. Millman, Helkias. And they have explained the things very well, but I will suggest you to go for some Indian author book first, because there are many technical terms that you may find difficult to understand. For the timing, we will use this circuit to understand our analysis. So this circuit, perhaps it is visible to you. In this circuit, what we see, we have a transistor, and what we are doing, we are using this as an amplifier. Now there are many components. There are capacitors 1, 2 and 3, CB, CC, CE. 3 capacitors are there. And this portion, let me highlight this portion with a different ink. This portion, if you have studied the bias stabilization lecture, then you can see that this is the biasing circuit and it is the potential divider bias. It is the potential divider bias. There are two resistances R1 and R2. You have an input resistance here, source resistance. This is the source. This is where you get the output. This source resistance is RS. This is the input resistance. Input resistance. And these are the capacitors. So this particular circuit, this particular portion which is covered in red line, it is the biasing circuit. It is the circuit that biases the transistor. So this is the part of the circuit which is used for biasing, proper biasing. And we have seen that this arrangement of two resistors, it is the potential divider arrangement. It is the self-bias circuit, and this self-bias circuit is the best for stabilization. It gives a stable Q point and stability factor is equal to 1. We have seen this in the previous lecture. So this self-biasing circuit is provided to fix the Q point and only after you have fixed the Q point, your amplification will be proper. So this is the arrangement, this is the circuit diagram of a CE amplifier. You can see that the emitter end is grounded. So this is a CE configuration, and in this configuration we use, with this configuration is used as the amplifier for amplification purpose. Now let us understand the details of this circuit. What happens here, this Vs, it is written in a very small size letter. Vs, this is the input signal, and V0 is the output signal. This is input and this is output. It is obtained across the load. Rs is the load resistance, and the most important concept that you have to understand is the use of these capacitors CB, CE, CC. Why these capacitors are used? What is the role of these capacitors? Now, whenever we are using capacitors, the basic concept is that the capacitor has a particular value of reactance, and this reactance is given as Xc is equal to 1 by 2 pi f C, where f is the frequency of the signal, frequency of the AC signal. This is the capacitance, this is the capacitive reactance, and it is analogous to the resistance. It is a quantity that is analogous to resistance, capacitive reactance. So when frequency is 0, in case of DC, this is infinite, and the capacitor behaves as an open switch, it does not allow any DC to flow through. So capacitor is a device that basically blocks the DC components and allows the AC component. And your source here, it is necessarily AC signal. So for DC, Xc, capacitive reactance, is infinite, and it will block all the DC components. So this capacitor CB, it has the function that it blocks all the DC components from the DC bias to the input source. No part of that biasing DC, it will go to the input. Similarly, if there are any DC components in the input, then it will block this DC component from the input to the biasing circuit, because if there is some additional DC, what you have done here in the biasing circuit, you have applied a proper DC to fix the Q point. Now suppose if there is if there is no CB, some part of the DC from the input signal, it goes to the biasing circuit, and this additional DC will disturb the Q point. And what we need? We need our Q point to remain unchanged. It should not change, it should be fixed. That is why this CB blocking capacitor is used. It is called blocking capacitor. It is essential that the input is, now again, this is the basic function of this CB, and this input signal, it should be properly coupled to the biasing circuit and the transistor circuit. Only then proper amplification will take place. So it is essential that the input is properly coupled to the biasing circuit, and for this any DC component in the AC has to be blocked. Only the AC part of the input signal should reach the biasing circuit, and it should be amplified. So the blocking of the DC component is also done by this blocking capacitor. That is why it is called blocking capacitor, CB. When you have a high frequency AC, you can see from this relation that if frequency is larger, then Xc will be very less, and it will behave like a closed switch. It will allow maximum amount of AC to pass through. And this is very essential. So this CB blocking capacitor, I think you have understood its purpose and its function. Blocking capacitor. In a similar manner, the roles of this CC coupling capacitor and CE emitter capacitor, they must be understood. This CC is connected to the output end or the collector end of the circuit. So CC prevents any flow of DC from the collector circuit, and again it keeps the Q point stable. remember that for proper amplification we have to keep the Q point static. So this CC, it will again block all the DC components and will act as an open switch, and it will allow the coupling of AC, it will allow the passage of AC only because of the relation of that I have shown you for the capacitive reactance. Now this CE, the capacitor here, CE, it is also very important. If we do not have CE here, there will be a voltage drop across this resistance RE, emitter resistance, and your output will be less. We do not require any voltage drop here. The voltage drop is occurring across this capacitor. This is called a bypass capacitor. You must have heard the word bypass. Means a different way. The voltage drop should occur across the collector, and there should not be any voltage drop in RE. To prevent this RE voltage drop, this capacitor is used. This is called the bypassing capacitor. These are the important relations. These are the important things that you should understand. The role of capacitors in a CE circuit. I have decided to keep the lectures in brief, so I am trying to express most of the things in a short time, and I hope it will be convenient for you, because long lectures are difficult to bear, I can understand. So this is the role of capacitors in your amplifier circuit. In the next section, we will discuss the basic concept of gain. What is gain and how it is expressed? What are the different types of gains? And then we will discuss the details of amplification process, the phase reversal and other things. So for the time being, please stay tuned, watch the videos and send your valuable comments. Thank you.